welcome to my channel, and in today's lesson we'll be looking at how to teach learners to factorize completely. There are various kinds of factorization, but today we'll just be looking at one kind.
For you to know factorization better, you must know this one. Highest common factor. And for you to understand this one better, you must start from the back. That means you must know what a factor is first. You must know what common means. And then lastly, H. Let us start with factor. Alright, I'm pretty sure that everybody knows what a factor is. A factor is any number that divides exactly into another number without a remainder. Okay, let's find all the factors of 16. Let's begin with 1. Let's see if 1 can divide exactly into 16 without a remainder. 16 divided by 1, answer is 16. No decimal. So 1 is a factor of 16. What about 2? 16 divided by 2, the answer is 8. So 2 is a factor of 16. So is 8. What about 3? 16 divided by 3, the answer is 5.33333. You can see the decimal part, our remainder. 33333 is the remainder. So therefore, 3 is not a factor of 16 because it does not divide exactly into 16. What about 4? 16 divided by 4, the answer is 4. So 4 goes into 16 4 times without the remainder. What about 5? 16 divided by 5, the answer is 3.2. Can you see the remainder? 2 there after the decimal point. We're not supposed to have that. If 5 is a factor of 16, it should divide exactly into 16 without a remainder, which is the decimal part. I hope factor is now known by you. And let us move to letter C, which stands for common. Before we move to letter C, all the factors of 16, 24, and 32 have been written. Okay, you can see these are all the factors of 16, all the factors of 24, all the factors of 32. Okay, now let us move to C. When something is common, in this case, factor, when a factor is common, it's appearing, or let me say it's a factor of all the given numbers. It's a factor of 16, it's a factor of 24, and it's also a factor of 32. Let us look for those factors that are common to all these three numbers. This one. 1 is a factor of 16, it's also a factor of 24, and it's also a factor of 32. Therefore, 1 is a common factor of 16, 24, and 32. What about 2? 2 is a factor of 16, it's a factor of 24, and it's a factor of 32. Yes, 2 is a common factor of all these numbers. What about 3? Do we have 3? What about this 3? 3 is not a factor of 16. It's not a factor of 16. 3 is not a factor of 32. Can you see 3 here? No. 3 is only here under 24, but it's not here. So 3 is not a common factor of 16, 24, and 32 because it's only a factor of 24. What about 4? 4 is here. It's a factor of 16. It's a factor of 24. And it's also a factor of 82. Yes, 4 is a common factor of 16, 24, and 32. What about 5? No, we do not have 5. What about 6? 6 is only a factor of 24, but it's not a factor of 16, nor of 32. What about 7? No. What about 8? 8 is a factor of 16, factor of 24, and a factor of 32. So 8 is a common factor of 16, 24, and 32. Now we have found out all our common factors. Let's write them. These are all the common factors of these numbers 16, 24, and 32. Let us move to letter H. Now, between these common factors, which one is the highest? Between 1, 2, 4, 8. Since these are the common factors of these numbers, which common factor is the highest? Obviously, this one is the highest common factor. It's a factor. It's common to all these numbers and is the highest. So there are other common factors 1, 2, 4, but then they are not the highest. We go for the highest one. So 8 is the highest common factor of 16, 24, and 32. It's the biggest number that can divide all these numbers. Now that we have done with the highest common factors of numbers, let us move to the highest common factors of variables. You can see that we have 3 terms. This is term 1, second term, and then the third term with 3 terms. Okay, now to find the highest common factors of variables, a variable must be common to all the 3 terms. It must be common to all these 3 terms. Let's start with variable x. Variable x is common to all the 3 terms. You can see it's here, it's also here, and it's also here. Okay, so x will join our highest common factors of numbers. How do we do that? X is appearing with different powers: x to the power 4, x to the power 1, and x cubed. Which one are we taking? We have to take the one with the lowest power. Between x to the power 4, x to the power 1, and x to the power 3, which one is the lowest? We have to take this one. Okay? And let us move to variable y. Is variable y common to all the 3 terms? We have y here, we have y here, and then y here. But then y is appearing with different powers: y squared, y to the power 5, and y to the power 7. Which one is the lowest? We have to take y squared. What about k? Is k common to all the 3 terms? We do not have k here. We only have k in this term and this one. But k is not appearing in this term. So k will not join the highest common factor of the coefficients. Let's write them down here. Okay, now that we know how to find the highest common factors of numbers which are coefficients, these ones are coefficients, And we know how to find the highest common factors of variables. Now let's find the highest common factor of this whole expression. To find the highest common factor of this whole expression, we must find the highest common factor of this coefficient: 16, 24, and 32. The highest common factor of these three numbers is 8. Next, we find the highest common factor of these variables. Find which one is common to all the three terms: x, y squared, and then we open the bracket. Before we factorize, I would like us to look at the rule of indices, which is the division rule. This rule says that if you find numbers in this form, dividing each other, and the bases are the same, and there's a division sign. Note that this time there's no a multiplication sign. This is a division sign. And the bases are the same. You must only write one base, and then these indices, you subtract them together. A to the power m minus n. And you must only do that when there's a division sign and the bases are the same. A to the power m minus n. This one is the same as this one. The answer is the same. The screen is busy, but please do not get confused. You are in good hands. Let me just explain the few things that I've added in. Any negative number divided by any negative number, the answer is always positive. Any negative number divided by any positive number, the answer is always negative. Any positive number divided by any negative number, the answer is always negative. Positive divided by positive, the answer is always positive. This one is the rule that you must know for you to be able to factorize completely. Okay? A to the power m divided by a to the power n is equal to a to the power m minus n. Okay, now what we are going to do is, when you found your highest common factor, you must open the bracket. And now we are going to divide every term of this expression to be factorized with our highest common factor. That means this term divided by our highest common factor. This term divided by our highest common factor. This term divided by our highest common factor. Since we have three terms, we must write three terms inside the bracket. Very much important. Take note. Because when we divide this term with our highest common factor, then we write it here. We divide this one, the second term, with our highest common factor, we write it here. And then we divide this third term with our highest common factor, and then we write it here. Okay, now, if there are coefficients, just divide it with a coefficient of the highest common factor. For example, there's a coefficient 16 in this term, and 16 divided by 8, this 16 divided by 8, the answer is 2. Now we have x to the power 4 y squared divided by x y squared. What is x to the power 4 divided by x? You can see that there's a division sign between x to the power 4 and x to the power 1, and there's a division sign, and the bases are the what? The bases are the same. So we must only write one base, and then we subtract the indices together. 4 minus this one here. You can see if we have same bases and there's a division sign, we must only write one base, and then we subtract these indices. So that's what we are going to do. X to the power 4 divided by x to the power 1. The bases are the same. So x to the power 4 divided by x to the power 1. We only write one x, and then we subtract the indices together. 4 minus 1. And 4 minus 1 is equal to x to the power 3. Are we together? X to the power 4 divided by x to the power 1. The answer is x to the power 3, because we have just to write one base, which is x, and then we subtract the indices. 4 minus 1, there's a power 1 here. X to the power 4 minus 1, and that will be x cubed. Okay, x is done for this term. What about y? This y squared divided by y squared. The bases are the same, y, and it's a division sign. So we just have to write one base, which is y, and then we subtract the indices together. 2 minus 2. And 2 minus 2 is equal to 0. So the answer is going to be y to the power 0. And any number to the power 0, remember, any number to the power 0 is equal to what? Is equal to 1. So we are not going to write 1 here. Because if you are to write 1 here, and 2 times 1, or let me say 2x cubed times 1 is just 2x cubed. So 1 does not change anything when we are multiplying. If you multiply anything by 1, you get something, the thing that we have multiplied. So therefore, here we are not going to write 1. Altogether, our first term is done. Then we move to the next term. Okay, we move to this one. We have to divide this one with the highest common factor. Look at the coefficients. There's negative 24 here. Note that I told you that this negative belongs to 24 because the sign belongs to a number on its right hand side. Okay, pay attention when a negative number is involved. A negative divided by positive, what is that? Negative divided by positive, the answer is always negative. That's why I've written my negative already there. Okay, and what is 24 divided by 8? 24 divided by 8 is equal to 3. Okay, now let us move to variables. X divided by x. The bases are the same, and there's a division sign. We just have to write one base and subtract the indices together. And the index of this x is 1, and the index of this one is also 1. So 1 minus 1 is equal to 0. So x to the power 0 is equal to 1. Any number to the power 0 is equal to 1, except 0 to the power 0. So I'm not going to write 1 there, because 3 times 1 is just 3. Let's move to y. Y to power 5 divided by y squared, and there's a division sign. The bases are the same. So y to power 5 minus 2 is equal to y to power 3. Or let's say y cubed. You can see it here. And then what about k? Do we have k outside the bracket? No. But then we can put it there if we want. We can even write k to power 0 if we want it. And then, because we know k to power 0 is just 1. Okay. Let's assume this k there in the highest common factor. K to power 1 divided by k to power 0. And then we just have to write 1k. 1 minus 0 is just 1. And that is k to power 1. You can see it's here. Okay, now our second term is done. Let's move to the third term, and it's our last one. 32 divided by 8. Positive divided by positive. You can see that. Positive divided by positive, the answer is positive. Positive 32 divided by positive 8, the answer is 4. And then we move to variables. This variable x. Okay. X cubed divided by x to power 1. And you can see that there's a division sign. Write only one base and subtract the indices together. X cubed minus 1. It's going to be x squared. Remember that x is raised to power 1. Okay, and then we move to variable y. Y to power 7 divided by y squared. The bases are the same. Write one base, we subtract the indices. Y to power 7 minus 2, the answer is going to be y to power 5. And then we move to this k. Again, let's assume there's k to power 0 here, because k to power 0 is just 1. Okay, now k squared divided by k to power 0. The bases are the same. K to power 2 minus 0 is just equal to k squared. K squared is here. Now we have done. The next step is just to see whether we have completely factorized this expression by checking inside the bracket. If you want to see whether you have factorized completely, you have to look at the coefficients. The coefficients are 2, 3, and 4. Though these numbers 2, 3, and 4 have a highest common factor apart from 1, no, there's not a number that can divide 2, 3, 4 apart from 1. What about the variables? Do we have a variable that's appearing to all the 3 terms? Let's look for x. X is here, but it's not here. Okay, what about y? Y is not here. It's only here and here. What about k? Only here and here. So the expression has been completely factorized. Thank you for watching, and see you next time. But do not forget to subscribe and turn on your notification bell so that when a video has been uploaded, you will be notified and view it. Thank you so much, and may God bless you.